Hi, I'm Richard C. I'm a tutor here at Wyzant, answering a question submitted by a student. This is a very early question in trigonometry. It's fairly simple to answer. I think the question really is, I think the student in this case perhaps is not familiar with some basic ideas in trigonometry, and so I'm going to try to cover some of that without going into tremendous depth. So that we can get the question answered. So the best way to think of this is you think of an angle, and we start at 0 degrees, so we would draw a line that's just flat like this, horizontal. If we wanted a 90-degree angle, this would be a 90-degree angle here. We move counterclockwise here, we're moving in the positive direction. This would be 180, 270, and then we'd come back here at 360. So as we move, you can think of it as like a hand on a clock. We're going from here, up to here, up to here, down here, and back. So let's continue with this clock analogy. If the hand of the clock were in this first quadrant, you can see we can draw a triangle here and think about that. If the angle is in the second quadrant, so imagine the hand of the clock going back over here, similarly you would have a triangle looking like that. If the clock went down here, this would be between 6 o'clock and 9 o'clock on a clock. You would look at that. And then if it were down here, you would look at that. Now we know that from SOHCAHTOA, the cosine of an angle, so the cosine of theta, is going to be adjacent over hypotenuse. And you can see here the adjacent coordinate, the x-coordinate here, would be positive, whereas the x-coordinate here would be negative. The hypotenuse of each of these triangles is positive, always positive. When you get to study the unit circle, you basically connect these and you form a circle. The radius of the circle, any radius of the circle, will be positive. Because the hypotenuse is always positive, in order for the cosine to be negative, the cosine must be, the angle itself must be in the second quadrant or the third. And we're told that it's negative root 3 over 2. So this distance here would be negative root 3. And then here's the angle of interest. And then this would be 2 here. So we need to find these angles. The easiest way to find them is to remember, you must have been taught at some point the special right triangles, 30, 60, 90, and the 45, 45, 90. Let's just look at the 30, 60, 90. From this 30, 60, 90 right triangle, we can see that the cosine of 30 is going to be adjacent, which is a root 3, over the hypotenuse, which is 2a. So this gives us our desired root 3 over 2. And we know so our what we call our reference angle is root 3 over 2, is 30. And so it must be here or here. Those are the two places for the reference angle. Now the angle itself is going to start at 0 and then come all the way around to here. So the green angle is going to be, it's going to be 180 minus 30, which would be 150. And then the other angle is going to be down here. We'll use another color. The angle is going to be down here. We always start at 0 and then come all the way down to here. And this other angle is going to be 180 plus 30. So that's going to be 210. So those are the two angles that produce a cosine that's negative root 3 over 2. So I hope that helps a little bit. It's a deceptively simple question once you understand the idea of the unit circle or any circle around the origin and how angles are measured in the positive direction and how reference angles come into play. So there are a lot of different things going on here. None of them are that hard, but if you just kind of pick apart the things that you're being taught in school, you should be able to work your way through a problem like this. Okay, well, that's it for today. I'll see you again next time. Bye-bye.